Okay, so we are going to do a small review of our square roots and irrational numbers. So first of all, remember our perfect squares, that is based off of, well, a perfect square. Remember, the square has the same same length on every side. So if this square had a length of 3 on each side, the area of this square is going to be one side times the other side, or the side squared. So if it is a perfect square, then the area would be 3 squared, or 9, meaning that 9 is something we call a perfect square. Now remember, we also can know that it is a perfect square because if we take the square root of it, and the square root of any perfect square number, I have them listed right here. The first set, 1, 4, 9, 16, 25. Remember how to get your perfect squares. If you take the square root of that, it's going to be an integer. So our square root is just the inverse or the opposite. So inverse means opposite of squaring a number. So for 9, I take, remember this funny little square root symbol, take the square root of 9. Now that's going to be equal to both positive and negative 3. And we talked about that. Remember, there's both a plus and a minus because I can square positive 3 and get 9, but I can also square negative 3 and get 9. But we call that positive square root the primary root. And remember, I gave you that term. The positive square root is the primary root. So if you see square root of 9 equals 3, they're just giving you the primary square root. All right. Now, if the integer, meaning this number here, is not a perfect square, if it does not end up on this line up here, please don't move the camera, John. It does not end up on this line here, then when you take that square root, that's not going to be rational. Now let's remind ourselves, what is a rational number? A rational number is a number that terminates as a decimal or repeats. So 1.2 is a rational number. 1.22222 and on forever is a rational number. But something like pi, 3.14, on and on and on, all the numbers are different, that's irrational. So if your integer is not a perfect square, then the square root is not rational. And so we talked about ways to estimate that without a calculator. And we use our perfect square method. So let's look at 18. 18 is not a perfect square. It's not one of these numbers up here. But we do see that 18 is in between 25 and 16, the two perfect squares. So we say, well, all right, 18 is less than 25 and it's more than 16. That means that the square root of 18 is greater than the square root of 16 and less than the square root of 25. And here we use the primary roots. We're just worried about the positives. And so that means that the square root of 18 is greater than 4 and it's less than 5. So our first approximation is that the square root of 18 is going to be approximately equal to 4.5. Remember that little squiggly line means about or approximately. Now that's if we are estimating to the tenths spot. Remember, this is the tenths. We can also estimate to the hundredths spot. And to do that, we take our first estimate, which is to the tenths spot, and we square it. So if it really was 4.5, if that really was the square root of 18, then when I squared that, I would get 18. So we square our first estimate, and when we do, that comes out as 20.25. That tells me that this number is a little bit too big. It's a little bigger than the actual square root of 18. So I step back one step and I say, okay, well, what would be 4.4 squared? Well, when I square 4.4, I get 19.36. Still too big. So I'm going to step back again and say, well, maybe it's closer to 4.3. So when I square 4.3, then I get 18.49. Still slightly too big. So I step back one more time, and I get 4.2 squared, and that is 17.64. Okay, great. Now I know that 4.3 is a little bit too big because when I square it, my number is bigger than 18. And I know 4.2 is a little bit too small because when I square it, it's only 17.64. So the real number is going to be somewhere right here in the middle. So my better estimate is that the square root of 18 is about equal to, not negative, about equal to 4.25 because that's the number in between 4.2 and 4.3. And you could keep going, but that's as far as I have you going there. Now, I didn't do a whole bunch of examples in this video. You can go back and you can look at the videos for square roots. You can look at the videos for irrational numbers. You can look at the videos for the estimating. But what you can do is, if this has been enough to remind you of what we were doing, you can go ahead and start working on your worksheet. If you are not ready to work on your worksheet, spend a little bit of time and go back over those videos. Now remember, the test is coming up, and when the test comes, then you need to give me all of the notes for all of your videos. So if you've lost any or you haven't been taking them, you need to start back all the way at the beginning and get that taken care of. All right, good luck, and I will see you tomorrow.